All right, so let's start with question 3. So we are told that a ball is dropped from rest, which implies that the ball is only in free fall. So the acceleration of the ball is equal to the gravity. So which means this ball has been dropped, that is number 1, which means it's from rest. So from rest, which means the initial velocity is 0 meters per second. It has not been thrown down, so it has been dropped. So the initial velocity is 0. But if it was thrown, then the initial velocity is not going to be 0, it's going to be something else. So just note the difference between dropping a ball and throwing the ball downwards. It only affects this part. Okay. So by dropping, you must know that it's experiencing a gravitational force, a gravitational acceleration of 9.8 meters per second squared. So that is the hint which we get from the idea that it was dropped. Okay, it's no longer on a straight line. So now we are looking in the y, which is the height. So the ball strikes the ground at 110 meters below, implies the change in y we are given, which is 110 meters. Okay, so if it strikes the ground which is below, then that is our change in y. Okay, so basically what we are going to do next, we are going to find the initial velocity and then we sketch like what the picture of what is happening. So this is what is happening here. We have our initial velocity, the ball is here, and then this is the distance which is below the point of dropping. So point of dropping until the ground, it hits the ground here. So we take downwards as positive, so which implies that our acceleration due to gravity is positive 9.8 meters per second. But if we are taken upwards as positive, our g is going to change to become negative. But now since we chose down as positive, our acceleration due to gravity is equals to positive. So we are given, always will be given these 5 number summary in each and every question in straight line. You must notice that you'll be only having 5 things which you must be having always. You must have your initial velocity, final velocity, change in y or change in x, acceleration or gravitational acceleration, and you must always have time. And you must notice that most of the times you have 2 unknowns. Okay, and most of the times in your equation you'll be already given 3 values which you already know. Okay, so what do? You have 2 unknowns, you can construct 2 equations, then you can solve using simultaneous equation, then you can solve for VF and T. And in this problem in particular, we're only supposed to solve for T. But however, I can show you how also to solve for VF. So like what I was saying, we have VF, which is, we are not told what is VF is, it's unknown. And we have V initial, we know it's 0. So it's a matter of just substituting the values and plugging in, and then we solve simultaneously. We have 2 equations and 2 unknowns, VF and T. These are the unknowns. So therefore we solve simultaneously. So by solving simultaneously, what do I mean? I mean VF is equals to 0 plus, that is my acceleration, 9.8 times t. It will give you our first equation. The second equation, VF squared 0 squared plus 2 multiplied by 9.8 times, this is our change in y. Okay, This is the change in y, the distance below, which is 110 meters. Acceleration, and this is the formula, 2g. Okay, that is our second equation. So now we are going to solve for Vf. So by multiplying 9,8 times t, you just get 9,18. Okay, and then next thing what you are going to do is going to say Vf squared is equals to, you are going to multiply what you have, which is 2 times 9,8 times 110, which will give you 22,156. So substitute equation 3 into 4 to solve for t. So this is our equation 3. Our equation 3, that is the equation 3. We substitute it into 4. This is equation 4 to solve for t. So equation 3 is this one. Equation 3, we substitute it into 4. So equation 4 is this one, which is this one. Okay, so you take Vf 9,8t, you put it inside. That is your Vf. Then you square. Is equals to 2,156. What do you do now? You divide both sides by 9,8, 9,8. Once you divide both sides by 9,8, it vanishes, and then this side will become 2,156 divided by 9,8. And remember, it's a square. Don't forget to square the t. Okay. So basically, this is how we'll be operating. So by simply just performing the algebra there, we are left with t squared is equals to that, and then you just square the right hand side. That's how you eliminate the squared, by square root of, which is just to the power half. That is square root. Then you solve for t, which is equals to 4,738 seconds rounded off. To 2 decimal, your t is 4,74 seconds. Okay, since we were not asked to solve for Vf, but I will just show you how to do it in case if you are asked how to solve for Vf. So Vf will be the final velocity the ball hits the ground. With what velocity is the ball going to hit the ground? So it will be the final velocity. So since we substitute, we know that Vf is equals to 9,8 from the first equation, which we have equation 3. So you know that Vf is equals to 9,8, then you just multiply by your time, and this will be your final velocity. And remember, Vf is it's a vector quantity. It has a magnitude and direction. So if you are asked what is the magnitude of the velocity when it hits the ground, you just put the magnitude. But if they ask you what is the final velocity, then you must include the direction. So you must note the difference between magnitude and direction of the vector. It must have magnitude and direction. Just a mere confusion. Sometimes if there's a negative, if they ask you what is the magnitude, you don't include the negative. Okay, you only put the positive number, which is they're just interested in the magnitude. That is the absolute, the positive one.